The definition of triangles. There are 4 types of triangles that we will go over. The first one is an equilateral triangle. An equilateral triangle has 3 sides that are equal. 1, 2, and 3. And when 3 sides are equal, we are also saying that the sides are congruent. Notice that there are little line marks right here, and a line mark right here, and also a third one right here. They are all one mark because all 3 sides of the triangle are equal lengths and are congruent. Because the 3 sides are equal, so are the angles. In a triangle, we have 180 degrees. If we divide it by 3, it is equal to 60 degrees. So each of the angle is equal to 60 degrees. The second triangle is an isosceles triangle. In an isosceles triangle, we have 2 sides that are equal. 1, 2, and so they are congruent to each other. Notice also the marking on the sides are different from the last triangle. In this case, the 2 sides that are the same have 2 marks, and this right here, the third leg of the triangle, has a 1 mark. So if this is a 1 mark, we're saying that this leg of the triangle is different from these 2 legs of the triangle right here. So if we have 2 sides that are equal, we have now is 2 angles that are equal. And so these 2 angles are equal to each other. Now, how do I know that these 2 angles are equal and not the angle up here on the top part? The leg of the triangle matches with the opposite angle of the triangle. So the opposite to the leg is this angle right here. The opposite of this leg of the triangle is this angle right here. So the opposite of the bottom leg of the triangle matches to the angle that's above right here. So because these legs on the sides are equal, therefore the angles down here on the bottom are equal to each other. So if we have 2 angles that are, let's say, 70 degrees, let's figure out what the third angle equals. So if we take our 2 70 degrees, add them together, we get 140 degrees. We subtract it from 180, and we have is 40 degrees. So the angle above is 40 degrees. Now also, the rule of thumb on the marking of the triangle is that if these 2 marking means that the opposite angle is larger than the 1 marking. So in this case, this is 1 marking because this is 40 degrees up here, and this is 2 marks right here because the angle opposite to the leg is this angle right here, which is 70 degrees, and 70 degrees is larger than 40 degrees. So that's how we determine the marking on the legs. Now let's look at another isosceles triangle. So this is a little bit flatter, and because it's 25 degrees on both sides, these are acute angles. So same definition, the 2 sides are equal. Notice the little marks are 1 mark right here, 1 mark right here. So they're opposite angle. Right here is the left angle. Opposite to this leg is the right angle right here. They're equal to each other. So they're congruent. The 2 angles are equal to each other. And so let's figure out is what our third angle is equal to. So if we take our 25 degrees, add them together, comes out to 50 degrees. If we subtract 50 degrees from 180 degrees, we get 130 degrees. So this angle on the top is equal to 130 degrees, and that's why there's 2 marks on the bottom of this leg, because this angle right here is larger than the 25 degrees right here. Now let's look at a third triangle, which is the scalene triangle. Notice that the legs are all different markings. We have a 1 mark right here, we have 2 marks here, and we have 3 marks. So what does that mean? It means that none of the sides are equal to each other. If the sides are not equal to each other, then the angles are not equal to each other as well. So now let's make some observation. Notice that this is 3 marking, which matches to this angle of 120 degrees. This is your largest angle right here. If this is 45 degrees, the opposite to this angle is the leg of this right here, which is 2 marks. So that means the angle that's left over right here would have to be smaller than this 45 degrees right here. So let's go ahead and figure out what our third angle is. If we add 120 degrees and 45 degrees, we're going to get a 165 degrees. If we subtract 180 from 165, we're going to get 15 degrees. So this angle on the top will equal to 15 degrees. Now let's look at a fourth triangle. So the fourth triangle is very similar to the last triangle that we just did on the scalene triangle, where the sides are all different. We have 1 mark on this leg right here, we have 2 marks here, and we have 3 marks here, same thing as the scalene triangle. So all sides are not equal to each other, which means that all angles are not equal to each other. But what's different from the right triangle and the scalene triangle is that you're going to make an observation over here in this corner. You're going to see a little square, and this is showing that this is a 90 degrees angle. A lot of times they do not write this 90 degrees right here. If they just show this little square, then you will know that this angle will equal to 90 degrees. So now let's go ahead and do an example where we know that this angle C right here is equal to 30 degrees. If this angle C is 30 degrees, what is angle A equal to? Well, if we add our 90 degrees and 30 degrees together, we get 120 degrees. If we subtract 120 from 180, we get 60 degrees. So this angle A will equal to 60 degrees right here. Okay. Now let's look at example 1. What type of a triangle is this? So let's go through the 4 definitions of the triangle. Is it an equilateral triangle? So you ask yourself, are all sides and angles equal to each other? Is it an isosceles triangle? Are 2 sides and 2 angles equal to each other? Is it a scalene triangle? Are all sides and angles different from each other? Or is it a right triangle where all sides and angles are different and it also has a 90 degrees angle? So what type of a triangle is this? This is a scalene triangle because all sides and all angles are different from each other. Example 2. What type of a triangle is this? Is it an equilateral triangle? Are all sides and angles equal to each other? Is it an isosceles triangle? Are 2 sides and 2 angles equal to each other? Is it a scalene triangle? All sides and all angles are different. Or is it a right triangle? All sides and angles are different and it also has a 90 degrees. What type of triangle is this? This is an isosceles triangle because we have 2 sides and 2 angles that are equal to each other. Example 3. What type of triangle is this? Is it an equilateral triangle where all sides and all angles are equal to each other? Is it an isosceles triangle? 2 sides and 2 angles are equal to each other. Is it a scalene triangle? All sides and all angles are different. Or is it a right triangle where all sides and angles are different, and does it have a 90 degrees? This is a tricky one because this is a right triangle but also an isosceles triangle, so it can be 2 triangles as well. Because we do have a 90 degrees angle right here, so this gives us a right triangle, but in this case it's a special case because the 2 angles opposite right here, so it matches the isosceles triangle definition. Example 4. what is the missing angle? So we notice that the angle C right here is given as 50 degrees. We notice angle A is 56 degrees. So what is angle B right here? We're going to go ahead and take our 50 degrees, add it to 56 degrees, giving us 106 degrees. We're going to take 106, subtract it from 180, and giving us 74 degrees. So angle B is equal to 74 degrees. What type of a triangle is this? So, of the four, is it an equilateral? Is it an isosceles? Is it a scalene? Or is it a right triangle? This would have to be a scalene triangle. So these are the definitions of the four types of triangles.